2 lines, 2 stories, 1 meeting point. Watch them cross.
Welcome to Foxglove Equation Path. Here, along this mossy woodland trail, we are exploring standard 8.EE.C.8a. Watch the scene first. The math is built into the world, so the quantities can be seen before they are named. As a red fox makes its way through the forest, we are going to track its path to understand a specific rule. A solution to a system of equations is simply the exact physical location where 2 graphed paths cross. This coordinate plane is built right into the tree roots, showing 2 mathematical paths. One root follows the equation y equals x plus 1, and the other follows y equals negative x plus 5. Notice how they meet at a single central junction. That junction, marked here on a stone as the coordinate pair 2, 3, is the exact point shared by both paths. To prove this mathematically, we test that coordinate. We substitute the x value of 2 into our first equation. 2 plus 1 yields a y value of 3. The path holds true. We run the exact same test on the second path. We substitute 2 into negative x plus 5. Negative 2 plus 5 also yields 3. Because substituting that single coordinate makes both mathematical statements true, the physical intersection point is the exclusive shared solution for the entire system.
The crossing satisfies both equations at once. That point is the answer.
But the forest is full of different structures. What happens to the math if we find 2 paths placed so they never cross at all? Here we see a woodland stream with 2 perfectly parallel branches acting as our lines. One traces the equation y equals 2x plus 1, and the other traces y equals 2x minus 2. You might wonder if they eventually meet further down the trail. If we measure the vertical distance between them, we can see their slopes are identical. That distance remains permanently equal, no matter how far they extend. Looking at the empty space between the branches, there is no physical junction. A single stone cannot sit on both paths at the same time. Mathematically, this means no single ordered pair can satisfy both equations simultaneously. Therefore, this system has no solution. If parallel lines result in 0 solutions, consider what it would look like in this environment if a system had infinitely many solutions. This diagram illustrates exactly that. We have 2 distinct equations that map perfectly onto the exact same physical trail, forming a single unified line. The word infinite here doesn't mean you can pick any random spot in the forest. It specifically means every single coordinate located along this shared path is a valid answer. Because every point on one graph is also physically located on the second graph, substituting any of those coordinates will satisfy both equations at the same time. When 2 graphed equations are identical and overlap completely, the system yields infinitely many solutions. Let's view all 3 environmental scenarios side by side to lock in the pattern. The physical crossing tells you exactly what to expect. 1 intersection equals 1 solution. Parallel paths equals 0 solutions. And an identical overlapping path equals infinitely many solutions. Mathematicians have a term for the collection of all valid answers for a given system. Whether it is 1 point, 0 points, or an endless line of points, we call this the solution set. As we step off the foxglove equation path, look back at the trail. Which mark in the environment proves the mathematical relationship, and how does the animal action make it true?
They met once. Both stories agreed there. Find another crossing?